mostly on the NAND device. They put their software. Okay, your OS is so not on the hard disk, because obviously in the you can't put the hard disk. That's why scientists have company develop their another software which is used to debug the. So you must have memory and RAM. What will do? It will do. Suppose you're running a code from here. What happened like this? I can let me take example. How it's work basically. You have CPU here. Okay, you CPU here, and here you have suppose RAM. How code works I can tell. Or here your code is there. Okay, code or any application is there. Application is there. How it's work basically. Okay, and this is the embedded system. Any embedded system story is the same. Okay, when you run it, basically what happen? It will not run directly here. It will first load to the RAM here like this. The program is loading here in the this hardware component. When you're writing the software load here, an application for example or anything is load here, then afterwards the software which is running, it will going to the CPU, and CPU see the commands, what are the code are there, what are the application want to do. On the basis of that, what his interface, like it has input output device, what you connected on that, it will send a command to that, right? Suppose want to then send the packets. Some audio packets are there. What will do? It will tell to the network interface card that some packet is coming for you. Please, you take it and now forward to the wire interface or the LAN interface. For example, suppose someone is setting to the speaker, right? What happened? Suppose you play the some video file, right? Video file here. Suppose example, what happened? It will load here first. Always load here. It sees okay, so video is coming now. What it will do? It will told to the video file or speaker that please play the video for that. So basically first any code will happen always load to the RAM, always RAM, and it is called the this type of memory we call the volatile memory. Why volatile memory means you only load this file or application when you run it. Simple. Afterwards it will delete from here, because when it's done, its work is done, it will get out from that RAM and flash. Okay, and again another application will come, and that's why you see your RAM always size is sometimes coming on the 4 GB, 8 GB, something like that. It's not 100 GB or 200 GB. Reason being, because at one time you can't going to run the 100 application at one throw, right? You load only one application of 3 application or 10 application. The 4 GB or 8 GB RAM is enough to load this application, right? You load application one, load 2, load 3, load 4, something. You load the application on the top on the RAM, and RAM will give the give the code whatever the here to the CPU, and CPU will see okay what this application need to do. Someone want to play the music, someone to stop it, someone want to play the PPT or document. On that CPU will do its task and give the command to the hardware which is required for that. Okay, now where the your code or application is residing, such memory we call as the non-volatile memory, NVM. And the memory which is required to load the application in this hardware we call the RAM, we call the volatile memory, right? So what happened now in this case, so where you save the your application, the non-volatile memory example is your hard disk. Okay, hard disk, and we call SATA disk, SDD, and NAND, NAND, and NOR. You can, if you want interested, you can read more about this, but these are the example of non-volatile memory where your application or code will remain permanently there. Suppose I have write the code here and put on the C drive, it will be remain there forever because it's a part of hardware HDD, hard disk, non-volatile memory. Okay, and the non-volatile memory and the volatile memory which is remain there. Okay, so now
Hello,
I
sir.
can able to, yeah, you are
Yeah,
asking.
this is Anumoy. Actually, this NVM is related to that NV memory from QXDM. That where can I put that true and false all that value?
Yes, that is, I think, it's a different one. Yes, that is the, yeah, NVM is true false in the quick HTML. Yes, you're
Hmm.
right. Yes, that's the similar. The non-volatile memory, which is basically is remain there. Then what happened in real time in the UI SD card even
Sir, your voice just got break.
Yeah, yeah.
okay
In
now,
between, your voice is breaking.
okay, not all okay. Now it's better. Okay, now I think you get the concept of this. Okay, now this is the hardware we learned. Now there is a concept called port. Port means obviously whenever in any hardware, it must have some port, USB port, LAN port, right? These are the port you require for that. For USB port, you require to put the keyboard. USB port is required for the uh, mouse, right? USB port is required for the dongle. LAN port is required for the LAN cable. So you need some sorts of port on the hardware. Okay. Now we need some sorts of sensor always. Sensor like for temperature sensor, you got some sensors require always for in your hardware, right? Sensor temperature, humidity temperature. That's why we come to know what's the current temperature.
Hello,
And
sir.
also, yes,
Sir,
hello, hello.
yeah. Sir, I just want to know a real-time example of NAND and NOR. Just an
Okay,
example only.
okay. So NAND or NOR actually what happened? These are the real example. For example, in your mobile, they are in mobile UE, the hardware system. They don't have SD card. They have NAND. NAND is a type of hardware which will store the application for you. It's a hardware device which will help you to put the on the application. The real example is your mobile phone, your watches, your smart watches, or you can say TV, even TV, your LED, or because where the software reside, where the operating system reside, we call the NAND or NOR. Basically, these two hardware required to put the application there, because in embedded system they use NAND or NOR, not
Okay,
SD
sir.
card.
As you told, it is a part of like volatile memory. After giving
Huh. Not volatile, non-volatile. Volatile memory is only RAM.
So
okay,
Rahul,
okay.
if UA is coming with like nowadays it's a 512 GB or 256
Mhm,
GB. So 256 GB is
mhm.
a NAND, right?
Yes, correct.
Okay.
256 GB is NAND. Yes, but yes, not other things. It's NAND device. If you learn more, obviously because it's not a part of curriculum, but just for the giving briefing. But NAND is 512 256 is NAND. You're right. Perfectly correct. Yes. Okay, I think it's make it clear. We know ports, we already know in the USB ports for mobile, we have USB ports are there, right? We have jack for the audio jack is there, right? So these are the, we have RF port is also there in the UE, right? Where you take the antennas, right? The antenna ports are also there. That we need ports always on the embedded system when you design it. And the sensor is always required. Sensor is means it can sense temperature sensors, humidity sensors. When you're doing the map, you got the sensor for that also. GPS sensors also there. So these are the sensors are there. And the last one is require the all require the analog to digital converter and digital to analog converter. What that mean? In real time, what we speaks, all the real time you can see they are analog in natures. Means what it means. Analog means suppose I can tell you. Oh, sorry, where I can make it here. Analog means what happened the like this. Whatever the like suppose I'm speaking anything in the real time, like you're driving a car is speaking always in analog in nature means something the wave will like this. For make it digital, you need some sort of hardware. Suppose I'm speaking right in the mic. It is analog. It's not a digital signal. You have to convert this analog signal, which I'm speaking, into digital signal. You required some sorts of hardware. We call the analog to digital converter. In every world device, you must have this component. What's the main component? Analog to digital. What we speak is analog. It convert to the digital. That require one chip in between. Suppose this is a chip here. We call the ADC. It convert real time. story, because when you're speaking the mic is obviously it's not digital. It's digital which we make in real world always in analog. Okay, it's always zigzag. The wave is always zigzag, no straight. We make to the digital. So that's why we need one called hardware, dot called the analog to digital converter. Okay, and when you're sending the thing to the outer world, obviously it should again analog, right? Because suppose I'm saying analog and it's converted to a digital. Now you're going to back. It's again the when you're hearing it's analog again analog, right? The life is first analog, then digital, then analog. Suppose I'm speaking something, it come to you, it again convert to at your at your place, it will become analog. For that you need again digital to analog converter, right? So this two hardware is always present on the most of the embedded system it require, because you see, for example, you're taking the pollution, for example, I give the example of some startup, they're doing CO2. It's obvious analog, right? What's going on there, the input is obviously this all are analog in nature. We have to convert the data into digital data, because digital data is easy to read, manipulate, change, analysis we can do with the digital data. Because digital data, because computers or mobile always read digital data, not the analog data. CPU never read analog data, they always read digital data. Okay, so these are the component of the a particular typical embedded system. It is applicable to any hardware or in the world, whatever you can think is consist of this. It's not come out from anything. You can take any example. For example, I will take the example of mobile, for example, because mostly from the telecom background. We have microprocessor. Yes, we have mostly. For example, what is CPU? Qualcomm, Intel. They give the microprocessor, right? We have IO device on the mobile. Yes, what the IO device means? Input output. What the input? When you putting the on the touch screen, you entering some data, right? Touch screen, that is the input. Output is when you are listening to the speaker, for example, is the output device, right? And for example, timer require, always timer require, because suppose you're doing some I told, right, you're playing something, you close the on and off, you require some sort of reference point, right? The timer start on off, right? You're doing something, you started your application on, timer started for that application, for example, it started 1 second, you close at 10 seconds, then timer will stop. You need some sorts of timer inside the hardware which will count the time for you when it start, when it stop, right? The it timer will help you to, because obviously in real time you need something, right, to stop and watch, stop and start, close. You need some sorts of reference timing. So this timer hardware will there on the mobile itself. Interrupt control is there also. Suppose you are playing something, you close something, you need always interrupt for that, interruption for that. So you need interrupt hardware. In the memory wise, you 100% you have RAM in your mobile device. That is the 100% and NAND is your hard disk that we call the 512 GB is that. And port we require USB port, RF port. Sensor is there, temperature sensor there in your mobile. And ADC is always you 100%. First thing is that when you make a call, when you speak, it is your analog. It will come to the mobile. It will convert to the, because the speaker is there, right? It will take input analog and convert to a DAC. That's what you see DAC. You might, I'm not sure, in the 10-20 years you might know DAC. You know DAC is playing. You notice that, I'm not sure. You people are saying DAC is playing in the in your marriage functions, but DAC is nothing but digital to analog converter, or analog to digital converter, something like that, right? So that's why in the mobile, all this component, any in your hardware in your lifetime, you see this are only these parts is present on the any embedded system, not any apart from this. That I can 100% bet you on this. It might be something less, something more, but it's only this part. Somewhat not require, for example, some is require HD, some are require NAND, some are no, but this only somewhat might not require interrupt control, some might not have uh, output, for example, some not have input. Like something is plus minus, but almost these are the only parts. Somewhat suppose not require temperature sensor, for example. Don't no need, for example, right? So why they will put it? It will not there in a calculator. Why they need the temperature sensor? They will not put. But the hardware design in any embedded system is consist of these sorts of only hardware. Okay, this looks like something here. I only make the picture. It's user interface, hardwares, ADC, tech, sensors, signaling, external data, something CPU. You can see the pictures and others. Okay, now the softwares. Obviously, now the $1 million question is that when 50 years back, what happened? There is no software there, right? Only their hardware device. So when you device the hardware, so what happened? The things are very manually. Like you can't control the things. for controlling the things, you need some softwares. That's the only objective. The only objective of software is to control of yours. You can control. That's why automatic car, they have softwares. That's why they put lots of software in the Tesla car, for example. In the UK, it's very often. So how? Just to control that embedded system. That's why we require the software. I'm not sure you get a chance to visit on the smart house. I don't have experience, but I get the chance at smart houses. You can control your house with the help of now a button. Simple. A smart home startup, they give a remote. You can control what you want. You can shut down your curtains. You can close, open your shut curtains. You can switch on, switch off, and from like you can do everything with the just remote in your sitting in your place. You can just have the display on your device remote, and you can do that. So they can make. So that's why you need some sorts of software to make the control for that. The controlling the software we call the embedded system, and the software is obviously the chunk of software required for that, and that's why the software industry evolved like anything. So I will go one by one. What are the software required? The software, first software I can tell you is the application software. Application software is what application software means. The software which is sitting on the top, basically. Top means which is visible to you, which have some application. That's why it's called application. For example, WhatsApp is application. Application to send a message. Right? YouTube is application. Google Maps application, which is has some application. That's why application means it has some use. Application means use, because the user software also begin. Another name of application software is called user software. It has some used, right? So you can give some example. I will like to ask to application software might be I like to ask